All right, I'd like to welcome you guys all to learn about our early wildfire detection system, codenamed Helios. Today, me and Calvin are going to be discussing what the heck this is all about. So unfortunately, Seth and Leonard could not make it to this meeting. There were scheduling conflicts and all sorts of wildfire related stuff going on in the world that they couldn't make it. So I'd like to continue on by saying about our sponsor of our project who gratefully helped us out in necessarily honing down our ideas and helping us like develop this project as we are new to what really this project came down to is computer engineering. So we want to thank Ada Core, our sponsor. They build mission critical systems for like aerospace, defense, and other medical industries. So they do a lot more computer engineering than strictly software engineering. So that's basically the main group funding this expedition. And moving on to like the next topic of what the background of this wildfire detection system, how did it come about? Basically, our idea was, well, they want us to build a satellite. We didn't know, they said an open-ended satellite could be anything we wanted. So we decided to focus on building a tiny cube satellite. It's just in the shape of a cube, very small, very containerized or whatever. And we wanted to just see if we could help the world out and get glory behind it and help mitigate wildfires. Because if we can detect it earlier and with decent, reliable accuracy, we can help from an ecological standpoint as well as economic standpoints to help people move about because it is difficult and horrifying to deal with. But this was also a great way to explore and expand upon the Ada ecosystem, which Ada Core is obviously a big fan of. They love Ada. It's literally in their name. But I want to talk a bit more into details about the specific needs for the project, as I was alluding to. Wildfires are actually becoming more common and dangerous for a variety of reasons, from whether it's poor forest management or climate change is wreaking havoc on our environment. There are current systems in place, but they're a bit antiquated and they have a lot of drawbacks. There's ground-based deployments, but if you have ground-based camera systems, it's just a sitting duck. It's gonna get consumed by the fire as it's there. Drones, you need someone to operate them typically, and they have specific flying restrictions. There might be no fly zones. So there's a lot more, it's more difficult for drones to just do that. And so what we're thinking like, okay, well, you can imagine that like when there's a wildfire, there's probably a lot of smoke and plume coming out. You might be able to see that from the atmosphere. And the idea was if you can view it from orbit, it'd be a lot easier to probably analyze a photo and be like, okay, that's cool. That's definitely a fire. And so this, like, once it's deployed, it's just going to stay up there. It's going to float down because obviously it's in orbit, so it's going to be constantly falling. And it's going to be in low Earth orbit, so it's a relatively quick orbit, probably like 90 minutes round trip. So this would help us bring firefighters in and hopefully help different regions around the world. But I'd like to hand it off to Calvin to talk more about more specifics about the project. So,
Thanks, Justin. So, being a satellite project, there are many constraints involved. First of which is just compliance with spaceflight regulations and specifications. This includes things like the geometry of the system, the mass, the magnetic field signature. It's very restricted in that regard. Also, radio signals emitted to and from the satellite. But we also had constraints when it comes to budget for things like hardware and electronics. We ended up going with an FPGA board, and so that has onboard memory constraints as well. The image resolution is also limited because there is a limited amount of memory as well. And ultimately, we have machine learning confidence scores constraints. Basically, the machine learning is used to predict wildfire location data based on real-time environmental data. So we have a vision of what this system is. Currently, users are able to send location data to the satellite system. They can also retrieve a photo from the camera taken by the satellite system. They can also view a system log, so any event captured, anything that happens on the satellite is logged, and it is able to be viewed. And finally, here is our working design. As you can see, we have the BASIS 3 FPGA board powered by the power supply, and on the right we have a camera as well. This is all connected and operating successfully through the USB connection at the top left of the image. That's where the ground station is and where the machine learning model is running to power the system. So thank you for coming to our presentation. That'll be all.
All right. Thank you all.